Hi, I'm Saman,
And I'm Jesse.
and we are doing a lab for Mrs. Pomberg's E-period calc class.
Lab is chapter 7. We have 7-2, problem 3, which is the integral of sine squared 5x times cosine to the fifth of 5x dx.
So, the most important step in this kind of problem is to identify the type of problem. As you can see, this problem has trig in it and exponents, powers. Therefore, it is an integral with powers of trig. Now, to solve an integral with powers of trig, there's several steps. If the integral has tangents in it, you would have to employ the Pythagorean identity for tangents, which is secant squared of x minus 1 equals tangent squared x. However, there are no tangents, only sine and cosine. If both the powers were even, we would have to employ the half-angle identities for sine or cosine and substitute it for both. However, you see that cosine has an odd power in this situation, so we have to use the Pythagorean identity for sine and cosine. The next step to solving this kind of problem is to factor out one of the term that has the odd power. In our case, this gives us sine squared 5x times cosine 5x times cosine to the fourth 5x dx. Never forget your dx. Now we have to employ the Pythagorean identity, which is sine squared x plus cosine squared x equals 1. We can manipulate this to give us cosine squared x equals 1 minus sine squared x by subtracting the sine squared x from each side. This is because we need to substitute back in for our cosine to the fourth 5x term. So we need to know what cosine squared x equals. If you look, you can see that cosine to the fourth of x is equal to cosine squared x squared. Therefore, 1 minus sine squared x to equal cosine to the fourth x would have to be squared. Now all we need to do is put a coefficient of 5 in front of our x to give us a 1 minus sine squared 5x squared term. Now this we can substitute that back into our integral, giving us sine squared 5x times cosine of 5x times a 1 minus sine squared of 5x squared dx. What you want to do is you want to square out that term. This gives us cosine of 5x times sine squared of 5x, just switch those terms, times 1 minus 2 sine squared 5x plus sine to the fourth 5x dx. Now you want to multiply sine squared 5x into the new term that we just multiplied out. It's really handy to keep the term that you initially factored out because it's really helpful in new substitution. Our new integral is cosine of 5x times sine squared 5x minus 2 sine to the fourth 5x plus sine to the sixth 5x, and of course dx. Now on to u substitution. So you want to set your u as sine of 5x. Trust me, you'll see how nice this comes out. So du, which is the derivative, is 5 cosine of 5x dx. Since there's a cosine of 5x on the outside, that makes it really easy to take du. All we have to do is put a 1/5 on the outside to balance the integral, and then we can substitute it for our u's. So we have 1/5 times 5 cosine of 5x times sine squared 5x minus 2 sine to the fourth 5x plus sine to the sixth 5x dx, and we can plug in a u for all of our sine of 5x's. This gives us a new integral in terms of u of 1/5 times the integral of u squared minus 2u to the fourth plus u to the sixth du. Now it's time to take the integral. So this is just polynomials, so taking the integral is simple enough. 1/5 times 1/3 u cubed minus 2/5 u to the fifth plus 1/7 u to the seventh is your result. You have to can multiply the 1/5 out to everything, which gives you 1/15 u cubed minus 2/25 u to the fifth plus 1/35 u to the seventh. Now it's time to substitute sine of 5x back in for all of our u's. This gives us 1/15 times sine cubed 5x minus 2/25 sine to the fifth 5x plus
So
1/35
there's your
sine to the
final
seventh.
answer, and we hope that you have learned how to do integration when it involves trig with powers. This is Jesse,
This is Saman.
and we hope you enjoyed our video. Thanks.
Já sei namorar, já sei beijar de língua agora.